Welcome to 5G Technology World. I'm site editor Martin Rowe. In June of 2020, Viavi Solutions added some features to its O-RAN test suite, O-RAN standing for Open Radio Access Network. In doing so, they added load testing of the Open Central Unit, sometimes just called the Central Unit, according to the O-RAN specifications. To find out more about that and about O-RAN in general, I spoke with Owen O'Donnell. Owen is responsible for marketing strategy and new product introductions in Viavi's wireless business unit. He has particular emphasis on virtualized 5G radio access and core network testing. He's a principal contributor of the company's test suite for O-RAN specifications. He has more than 30 years' experience in the industry with positions at Ericsson and Huawei prior to Viavi, and he has lived and worked in Sweden and the UK and is currently based in Ireland. So, Owen, thank you for taking some time to meet with me today. And we're going to talk about O-RAN, Open Radio Access Networks. And I know that Viavi is heavily involved in test equipment for O-RAN and for other parts of the wired network. Can you tell me about O-RAN? It seems to be gaining momentum. What is its current state?
Very good. First of all, thank you, Martin, for allowing me this opportunity. Yeah, I'm thrilled to be talking to you today. So I think O-RAN, it's in a healthy state, by the way. I think 2020 has seen a very good adoption of the industry towards the O-RAN ecosystem, if you like. One of the measures I would use to see how it's being adopted is the O-RAN Alliance, which has, I remember last October, doing a presentation about the O-RAN Alliance. And at the time, there was 22 operator members and 101 contributing companies, of which Viavi is one. And then yesterday I looked, and the number of operators is up to 26, but the number of contributing companies is up to 164. Now, that's actually a really good indication of how many companies are taking O-RAN seriously. If they all want to contribute towards the spec and the centers, the OTICs, which is the Open Test Integration Centers, which are also being set up for interoperability testing. But coupled that with the regular announcements in the daily media about O-RAN activity, which is hitting us more and more, and also the recent Microsoft acquisition of Metaswitch and Affirmed Networks, showing that they have ambitions to get into telecommunications via the O-RAN door, if you like. I would say that the momentum is definitely with O-RAN Alliance and O-RAN, all things O-RAN, if you like. Further, we had the launch of the Open RAN Policy Coalition back in May, which again is another, if you like, forum or alliance which is looking to cement the O-RAN ecosystem into the lives of the telecom operators and vendors. So there's a huge number of activities all happening at the same time, and I think the momentum is looking really good for O-RAN currently.
So O-RAN really is the disaggregating of roughly three functions that up until now, or really still going on, of the radio access network, starting with the radio, going back towards the core. And there are roughly three functions called the radio unit, the distribution unit, and the centralized unit. How do they all fit into the overall ecosystem?
Okay, so that's absolutely correct. So what O-RAN does is it takes the traditional base station, if you like. So up to recently, when an operator purchases a base station, it comes in the form of a baseband unit, a BBU, which sits in the cabinet at the side of the road, and then beside it you've got this mast, at the top of which you've got the radio unit. Now, You would tend to purchase all of that equipment from one vendor, because it tends to work together because it's a closed interface, and the radio unit would work with the distributor or the BBU over this closed interface, the CIPRI interface. Now ORAN is taking the BBU and splitting it into two units, the DU, which you mentioned, and the CU. And as well as that, you still have the RU, the radio unit, at the top of the tower. However, those three units are now in this distinct individual units with open interfaces between them. The idea being that different vendors can concentrate on the part that they think they're best at producing, and thereby giving operators the choice of mixing and matching components from different vendors, which will work together because of the standardized interfaces between them. Does that make sense?
It does. And the different units, now the radio unit we can understand, that's part of it is the radio. But in terms of dividing or disaggregating, seems to be the commonly used phrase. How do those distribution unit and centralized unit, what are they? Are they entirely software? Where would they reside? And can they be in different places depending on the architecture of the network?
Yes, indeed. So they can indeed reside in different places. First of all, the idea of ORAN also is that it delivers software on top of, they call it white box or x86 processor hardware. So it's virtual software delivered on standard off-the-shelf servers, which takes away the proprietary hardware that you would have had traditionally with the RAN vendor. And that allows the cost to come down and also the mixing and matching to take place. Now, when it comes to the situation of the different units, you can have many RUs to one DU, and you can have many DUs to one CU. So you're kind of aggregating as you go up towards the core network. And that CU, that central unit, can now become a very important aggregation point from a traffic point of view, because you could have a huge amount of traffic coming from all the RUs into all the DUs, eventually stopping at one CU. And that's an important point when it comes to testing these new points, because that could become a very important single point of failure from the ORAN ecosystem. Now, location-wise, they can be located in different places. You will have this, the distance between them will be dictated by the delay tolerance that's allowed between the ORU, ODU, and the ODU and the OCU. So again, you have a tolerance delay, which will dictate how far they can be apart, but they can indeed be located in different locations.
In terms of interfaces between these units, you mentioned CPRI, CIPRI, as the interface between the radio unit and the distribution unit. But then there's another interface that I've heard a lot of talk about called the F1.
So first of all, you're correct that the interface from RU to DU is the eCIPRI interface. And then from the DU to the CU, it's the F1 interface. And what it is you've got an F1 control plane and an F1 user plane. So across the user plane, it's just the data. It's just the voice traffic and video traffic that's always going on. And on the F1C is the control plane signaling. So all of the messages which are used to set up and tear down and hand over calls, they all go across the F1 control plane. So that's how the F1 interface is split up between the DU and the CU.
And you mentioned earlier something about compliance and interoperability and setting up testing locations. Can you expand on that and explain and tell us what will be involved in compliance, interoperability testings, and where will that take place?
Yeah, so one of the biggest challenges with ORAN ecosystem is the fact that you now have equipment from different vendors being placed in the one operator's network. And who's going to take responsibility for that interoperability testing? And that's quite a big challenge, because the different vendors will do a certain amount of interoperability testing, but they cannot do it against every option out there that's available. So that's up to the operator to take on that role. Now, there's already actually centers called OTIC, which is Open Test and Integration Centers. And these are plug and play centers. There's a few of them set up around the world where vendors of ORAN equipment can bring their equipment and have it plugged and played and interoperable with other equipment in the ORAN ecosystem. And then at the end of it, get a cert to say that their equipment works functionally with other equipment. So that's one option where you can do interoperability testing. But the operators themselves will probably want to do a certain amount of testing themselves, because they want to make sure it works in their network with their traffic patterns and their subscriber base. And that's where they will need their own test equipment and test lab. This has to be done in the lab, because you cannot do testing in the field, otherwise you're going to have in-service performance interruptions. But the idea of testing from a conformance point of view, first of all, you need to check that the unit works and does what it should do on its own. So you can isolate the CU or the DU, and you can check that it performs its function in isolation. Secondly, you need to check, does it work with other equipment attached to it? And that's interoperability testing. But then beyond that, you also need to do load testing. You need to test it and stress test it with some real load of traffic to make sure that when it is highly loaded, that it doesn't fall over, because these will be very important points in the radio access network. And finally, you need to do error insertion. So checking it all works when everything's perfect is good, but what happens then when errors are introduced? So there's a kind of a sequence of testing. You've got functional testing, you've got interoperability testing, you've got load testing, and then you've got error testing. So all of those need to be done before you can launch with confidence in the field.
Now, granted that testing, putting all of these pieces together and testing them is going to be a significant portion of the integration process. What other issues might come up in terms of integration?
So one of the concerns I think that will be raised is kind of the blame game. Who's at fault? So when you have an ORU from vendor A, an ODU from vendor B, and an OCU from vendor C, which is going to be possible, and then the KPIs, which the operator is so important that the KPIs that he's used to are no worse than regular KPIs from, if you like, a traditional vendor. So in introducing ORAN technology, they have to be sure that the performance of the network will be as good, if not better, than it was previously. Otherwise, they're taking a step backwards. So when they're doing their testing of the new integrated ORAN parts, they need to make sure that if one part is failing, they need to be able to identify which that is. And very often, you know, the ORU vendor or the ODU vendor will say, well, it's not me, I'm working perfectly fine here. So that's where you need very good visibility of statistics and KPIs and workflows or traffic flows all the way through end to end. So you can see where the latency is introduced or where the messaging is not going through correctly. So that's going to be a big challenge, so that the finger pointing is eliminated with this mix and match type scenario.
Is that the role of test equipment?
Indeed, it's the role of both test equipment and the test environment, whether that's an integrator. You may find some companies now acting as integrators of this equipment, and it will be their job to make sure that the equipment works together in this environment. But it's the test equipment eventually which will help identify which of the units are underperforming. Yeah.
What does Viavi offer in terms of the compliance interoperability testing that these carriers are going to have to, the carriers and other labs, other locations will also have to perform?
So we already have emulation tools at the moment. So we have RAN emulation tools and core emulation tools, which allow the system under test to be tested with environment emulated outside of it. So we can generate traffic, we can generate errors, and we can emulate what's not being tested so that the system under test is getting a full wraparound test. But when it comes to the ORAN ecosystem, we're introducing new test tools, and these are already being developed, being sold, and we're enhancing them. So for example, you can test the CU, the central unit, by having a DU emulation. So we would emulate the DU, the distributed unit, and then we would generate traffic over that F1 interface we talked about a while ago. So we would generate control plane traffic and user plane traffic into that CU under test. And we could also emulate other base stations so that the XN interface, which goes from the CU to another CU, that can also have traffic generated into it. And on the other side of the CU, we can emulate the core network. So from a testing point of view, you've got the CU in the middle under test, and Viavi can emulate the DU, the base station, and the core network so that all elements are wrapping around that CU under test.